Now that we've solved the equation, our next question should be, how do I correct my work? How do I make sure my answer is right? Now, it's important to check your work so that way you can catch any mistakes you might have made, so that way your answer is accurate, your answer is correct. So the first thing we should do is our check. We already know this. We plug the solution back into the original equation, check our answer with the original equation, solve it, and see if it works. If it does, if the check works, then our solution is correct. We get our smiley face, and we draw that check mark, and we're good to go. We can stop there. If our check doesn't work, though, that means our solution is incorrect. Now, we're good at catching this if it's incorrect. But how do we actually go back and fix our work? Well, we should go back to the steps. We should go back to the steps of our equation and see if they are actually right. So we're going to use an acronym, SOCKS. That means that the letters are going to represent words. So we're going to check our SOCKS when we go back to the steps. The first one that we should do is that S for signs, positive or negative. Sometimes when we're doing our work kind of fast, we forget that some terms are positive and some terms are supposed to be negative. You gotta make sure that if a term starts as positive, it stays positive. Or if a term starts as negative, it stays negative. Or maybe if we're multiplying and dividing, we remember that positives and positives give us positives, and negatives give us positives. So we gotta check our signs for things like that. The O in SOCKS stands for operations. So we have to make sure that we added when we were supposed to add, and we didn't accidentally multiply instead of dividing a number. So actually go back and check if you did the correct operation. The third thing we could check, that C stands for calculations. All right, so those are the actual numbers and math that we're doing. We're going to make sure that if we added 2 plus 3, we got 5. And we didn't accidentally do 2 plus 3 equals 6. Just go back and check the actual math that you did there. And if it's not those three, those are the three most common mistakes, then we go to our final S. Our final S stands for something else. If it wasn't those three common mistakes, maybe we wrote down our equation wrong. Maybe we wrote the wrong number when we went to our next step. It could be really anything. But we want to check the three most common mistakes, and we want to look for anything else that might be a little strange and throwing off our answer. Let's try applying this to an example. So for this example, this is actual student work from one of our homeworks. And now this student actually went and did all of their work. They got 12 for this equation. They went back and checked their work like they were supposed to, but then they found that the check didn't work. And so they weren't quite sure where to continue from there, how to go back and fix their actual work. So that's when they went and asked us teachers where they might have went wrong. But the very first thing that they did was check their work. They got 71 equals -1, which is not quite right. So that was their first sign that something was wrong. So from there, what they should do is use SOCKS, right? We want to check our SOCKS. So we'll go to each step and check for signs, operations, calculations, or if something else is a little off. So let's take a look at that first line. That first line should just be copied from the original equation, so it looks good. We'll move on to the second one. For the second one, it looks like the student multiplied that 5 and distributed it to the 6y and the 7 in the parentheses. So we have 5 times 6y plus 5 times 7, and then we just brought down that -27y equals -1. That line looks pretty good, so we move on to the next line. This third line has 30y, which they got from multiplying 5 times 6y. Then we had plus 35, which they got from 5 times 7. And then they just brought down that -27y equals -1. That line looks great, so we keep moving. This fourth line, we have 35 minus 3y equals -1. Now, that minus sign for 3y, it looks a little off. Let's take a look back a step to see how they actually got that. So we had 30y there and -27y there. And those are the two common like terms. So the student did try adding them, right? But they mixed up their signs, the first S of signs. So 30y minus 27y is actually going to give us a positive 3y. But it's the same thing as 30y plus negative 27y. It's going to give us a positive 3y. So we change that to a plus sign. Now we have 35 plus 3y equals negative 1. Then the student subtracted 35 from both sides. And we can look at our next line. We have that positive 3y equal to 36. Let's take a look at that 36. If we go back a couple of steps, we see that there's a negative 1 minus a 35. A negative plus another negative is going to keep our answer negative. So we draw in our negative sign for 36. It looks like they just missed that sign here. And so we actually have 3y equals negative 36. Then the student divided by 3 on both sides, which looks good. But that negative 36 is going to throw off our answer a little bit because now we have a negative divided by a positive, which is going to give us a negative. So right there, we should draw in our negative sign for that 12. And our answer is now negative 12. And from here, since we've corrected our work, we should go back and do our check one more time and make sure that negative 1 does indeed equal negative 1, and therefore it's correct. And now our work's correct, and we can stop there. But that's how we can go back and correct our work when we're solving equations.